Hello guys, this is Sri. So in this video, we are going to see about the uh, transaction levels in Galera cluster. So we already published one video which explains the different types of transaction isolation levels in MySQL in the demo, so you can check it out. Anyway, in this video also, we will see a slight overview about the various types of isolation levels. Then we will go how that is differ from the Galera cluster. I mean, that how that transaction isolation levels are working in the Galera cluster. Okay. So I think this video will be helpful. And also, a few of you guys are asking to publish the video to install and configure the Galera cluster. So I will try to post it as much as possible. Okay, so let's go into the topic. So these are the basic agenda. We will see about the overview. Then we will see the demo about the basic about the isolation levels. And then we have the special isolation level in the Galera cluster, which is called a snapshot isolation level. We will see the demo for that as well. So I think that will be helpful to understand this better. So first of all, what is isolation level? So we know the ACID property, right? So atomicity, consistency, isolation, and durability. So here this I stands for the isolation. So so this is the transaction properties. And what isolation defines is how the transaction is isolated from for the other transaction. So for example, we have the database and multiple users can access the database from different sessions, right? Different users from different sessions. So here the transaction, how the transaction, how the data is transactional data is isolated from one session to another session. Okay, so yeah, I will show in the demo, so that will helpful to understand this better. So why this is needed is, for example, let me tell you a simple example. So you are trying to book a movie ticket and you already selected two seats. And some other guy is also logging the app and he is also trying to book the movie ticket. And so you already selected two seats, but you did not book it, but you already selected. So in that case, that two seats should not visible to the other guy, right? So if that two seats are visible for the other guy, then again it will be the conflict, right? Then you both book a same seat and there will be the issue, right? So so this is the like a basic example why the isolation is needed, right? So this isolation level properties will define that whether your the seats which you are selected is need to visible to the other guy or not. So that is how this isolation is works in the transactional database. And Galera cluster supports isolation levels. And we have four types of isolation levels. One is read uncommitted, read committed, repeatable read. That is the default isolation level in MySQL. And we have one more isolation level, which is serializable. So for now, Galera cluster supports first three: read uncommitted, read committed, and repeatable read. Serializable is currently not supported in the Galera. Okay. And also, as I mentioned, we have one more isolation level in Galera, which is the snapshot isolation level. Okay, fine. So let it keep as it is. First, we will try to understand what are this isolation level and how they are working. Okay, so if we understand this better, then we can move for the Galera. Okay, and here I created three nodes, Galera 1, Galera 2, and Galera 3. We have this three node Galera cluster. So for example, let me log in. And also in this video, we will also go through the Galera replication architecture. slightly. So I think as a part of this, so yeah, keep watching. So here, you just log in the first node and let me do MySQL. And here you can see we have the cluster size is 3. We have the 3 node Galera cluster. Okay. So now I am not going to log in the other nodes. So we are going to just log in this first node with 2 sessions. In the session 1 also, I'm going to log in. Yeah. We have the parameter there. Using that, you can set it which isolation level you want to use. Okay. The parameter name is tx underscore isolation. Yeah, so I am using MariaDB 10.6. Okay. In MySQL, I think the parameter is name is different. In MySQL, the parameter name is transaction underscore isolation level. As I mentioned, the default isolation level is repeatable rate. Okay. So now we have 2 sessions, and you can see both are the same node. Srivlog Galera 1, Srivlogs Galera 1. Okay. So now what we are going to do, we are going to set the 4 types. Like first we are going to see how this read uncommitted work, then how this read committed work, then how this repeatable read work, and how this serializable work. Then we are going to see the how this isolation levels work in the Galera cluster. And also before going to see this, we have 4 major components that we need to understand this isolation levels better. Okay. So for example, dati reads, non-repeatable read, and phantom rows. Okay. So each of these isolation level have the benefit of overcoming the previous drawback. So for example, first level is read uncommitted. Here it allows the dati reads. Okay. And when we come to the read committed, it blocks the dati read and allows the non-repeatable read. And repeatable read is blocks the non-repeatable read and allow the phantom rows. And when the final isolation level serializable blocks the phantom rows as well. That is completely your transaction is isolated. So this is the each of this level. First level is read uncommitted, then read committed, then repeatable read, finally serializable. Fine. So now, yeah, now just forget about the Galera cluster. Just we are going to understand how this isolation level works. Okay. So for that, we have one MySQL. Yeah, let's assume we have only one MySQL node. And here TX isolation is isolation. Repeatable rate, that is the default one. And as I mentioned, both is the same node only. For the same node, I just created 2 sessions, 2 logins. That's it. Both are the same server. Okay. Now, let's try to understand the read uncommitted first. And I have created one database as well, Sriblogs, and there we have one table. Table name is T1. And there we have data 3 rows. 3 rows data. We are using this table to test the different isolation levels. Okay. So first of all, let's do read uncommitted. So let me make the change. Set global. This is the dynamic variable. You can change in the runtime. The new connections will be affected with the changes. Okay. Isolation. There is a typo. Isolation. Read uncommitted. Isolation. Cannot be set value. Let me see. I missed something maybe. Okay, so it should be the hyphen instead of the underscore. Okay, so now I made this change. And now let me reconnect both the connection and now checking select added isolation, which is read uncommitted. Okay, so now in the first session, I'm going to begin one transaction. By default, MySQL is auto commit. So in case if you want to do some test or you want to write some transaction, you need to use the begin. Then your transaction is open. Then until you give commit or rollback. Okay. Now inside the transaction, select start from T1. So these are the data I have, and here select start from T1. I have the same data 1, 2, 3, ABC. That's it. Now this in the session 1 transaction is open. I'm going to do update T1 set name equal to some value. Instead of C, I am giving CC, where ID equal to 3. Okay, I just made one change, but uh, the changes appears inside the transaction. I did not committed this transaction yet. I just opened the transaction with begin, but I did not committed this transaction. But from the different session, I can view the change. Okay, my transaction is open here, but I did not committed it. But still, the other session, the other user can view the modifications before the commit. This is called the dirty reads. Okay. So with read uncommitted isolation level, dirty read is possible. Okay. So this is mostly, I think, from my experience, people do not use this isolation level because, yeah, from our example as well, the same cities appears for me, and I can modify the seat, and the other user can also still can access that, right? So this is something um that is not much isolated. This is the first level of the isolation level. Before commit the transaction, I can still see the modifications from the different sessions. This is called the dirty read, and this is how read uncommitted work. Fine. Now let me roll back this. So when I did roll back, I will see the previous value, and here also I don't see the previous value. Fine. Now, so this is how read uncommitted work. Now let's make the change with, let's see how the read committed work. Okay. So for example, control set global. Okay. I'm just removing, reconnecting the session. Here also reconnecting the session. Now checking select added tx underscore isolation. Now it is read committed, right? Now let's see how this is worked. In the same thing, in the session 1, begin and select start from T1. I have this value, and here also I have the same value. Now let me do one update. Yeah. So update T1 set name equal to CC, where ID equal to 3. I just did the same way what I did before. Now let's check in the session 2. The change is not appear. So dirty reads are not happening, which was happened in the read uncommitted. But now we change the transaction isolation level to read committed. With read committed, the dirty reads are not possible, right? So we are overcoming the dirty reads. Once this transaction commit, now I can see the changes from the different sessions. Okay. So this is called the, this is how the read committed work. So here we are overcoming the data reads. But as per this, it blocks the data reads. Yes, that blocks the data reads. And it allows the non-repeatable read or possible. So let's see what is non-repeatable read. So same thing in the session 1. I am doing the begin and I'm giving select star from T1. And in the other session, other session in the same server, other session, begin, update, T1, set name equal to z, where id equal to 3. Okay. And let me commit this from the different session. So what happened? I just open the session and I read some value. 1, 2, 3, A, B, C, C, that value in the session. In the other session, I created one transaction and I did the modification, name equal to Z, where ID equal to 3, and the transaction is also committed. Now let me come to the session 1 and I'm checking the data inside the same transaction. I am getting different values for ID equal to 3. Inside the same transaction, I am getting ID equal to, name is CC for 3 and name is EZ for 3. So this is called the non-repeatable read. Inside the same transaction, I can see different values for the same row. When I'm doing the select multiple times in the same transaction, I can get the different result. That is something can create the issue within the transaction. Okay. So this is called the non-repeatable read. Getting the different value for the same select, which is called the non-repeatable read. So this is possible in the read committed isolation level. We can overcome this with repeatable read. So you can see the definition. Repeatable read blocks the non-repeatable read behavior, but it allows the pandemic. So now let's see how the repeatable read works. Okay. Yeah. So now let me just commit this and let's do clear and let me set isolation level to repeatable read. Repeatable read and reconnecting here as well. Select at tx underscore isolation. You can see currently the isolation level is repeatable. Fine. Now let's do the same experiment. Let's try to reproduce the non-repeatable read, which is the drawback of read committed isolation level. Right now, let's try to reproduce it. Begin. Select star from T1. Here also begin. Just doing the update. Now name equal to triple Z, where ID equal to 3. Commit and select star from T1. This data is showing here because, yeah, this is committed. I just completed one transaction. Begin and commit. And within the one update, the data is modified. Now, let me come to the session 1 and trying to do the select star from T1. I can see the same result which was executed with the first select statement. 3 equal to Z set. But we committed the other transaction from the different session, right? That change is not visible in the session 1 within the transaction. So the select is giving the consistent read view, right? So this is, so that non-repeatable read is not, I mean, we are just avoided. That is we can see in with read committed isolation level, right? We see the different result right here. But with repeatable read, within the transaction, the same select statement giving the same read view, same result to make the transaction to consistent more, right? So repeatable read blocks the non-repeatable read, but the phantom rows are possible. Yeah, let me give one overview also how this repeatable read give the same result even the other session committed the modified the data. So repeatable read isolation will take the snapshot of your select statement and it will keep that snapshot to entire transaction to make the read view consistency. Okay, it's fine. So I also planning to create one video with that involves the multi-version concurrency control and history length. So undo lock. So probably I will do that as much as possible. Okay, so now let's come back to this isolation level topic. So we are just avoiding the non-repeatable read with the repeatable read isolation level. As I mentioned here, it allows phantom rows, right? It allows phantom rows. So now let's see how these phantom rows are getting created. Fine. So let's do the same thing. Begin select star from T1. Now we can see this result and begin select star from T1. We can see the same result here. And let me do update T1 set name equal to Z where ID equal to 3. Okay. And let me commit. Yeah. So anyway, this is not going to visible here, right? So we did this. Now just we make it see when we committed the transaction as well, but it is not showing here because we have the transaction isolation level is a repeatability, which do not allow the non-repeatability read behavior, right? So this is how repeatable read work. Now let's see how this phantom rows can occur. So for example, update T1 set ID equal to 100 where name equal to Z. So this is usually not possible more in your most, I mean, in the most of the applications, the code was designed to avoid the phantom rows only. Okay, so I don't think I need to worry about it. But still, uh, I'm trying to explain how this phantom rows occurs, phantom reads or phantom rows occurs. You can see now, I made the update for ID equal to 100, where name equal to Z, right? So you can see this Z is now showing here and the change for ID is also 100. So this Z is, we did the change with the differentiation, right? And here I just modified ID column only 100. I did not change the name column here, right? Name column Z is changed in the differentiation. But when I'm updating the same row in the same transaction, I can see the changes from the other session. So this is called the phantom read or phantom rows. So let me do one more, show me one more example. For example, insert into T1 values. Let me give 4 and A. Yeah, so that is a gap log. Fine. So now let me begin select star from T1, and here also control L, and let me do the inset. Now I just did the inset and select star from T1. I have 4 rows now. This inset is already committed because I did not started the transaction with begin and commit. So MySQL do the auto commit. So it is already committed. I can see the 4th row here. But when I see here, I still can see the 3 rows only. That is how repeatable read work. It will just keep the snapshot of the first select and it will keep it for the entire transaction. Now let me show you how this phantom rows occur here. Update T1 set name equal to some value D where ID equal to 4. And let me do the select. I can see the 4th row here. So this is the phantom rows. So yeah, what I'm trying to convey here is, so this is usually not possible. The phantom rows are based on your application design. I did not see this phantom rows behavior much, but still for our understanding, what is phantom row, how that can occur. So just trying to explain how that can appear. Okay, so in simple way, usually repeatable read will keep the same read view for the entire transaction, but any transaction, I mean any row change from the different session that will not impact here by default, but within the same transaction, if we do some modifications, update or delete, for the data which is modified by the different session, then the select that read view will, I mean, you will get the different result for the select. So that is called the phantom rows. Okay. So I think that I explained this well. But yeah, in case any doubts or questions, you can post in the comment. I will try to answer it. Now we can go for the serializable. So we avoided the non-repeatable read, select statement given the same result. And yeah, it allows the phantom rows. That is also we see how the phantom rows or phantom reads are acquired with repeatable read. Fine. Now the final one is serializable. So as I mentioned, the serializable transaction isolation level is not supported for the Galera cluster. It is not supported. Yeah, maybe it will get deprecated in the further release. Okay. So serializable isolation level is not supported here. But let me try to explain how that serializable is working as well. Okay. Yeah. Set global TX isolation equal to serializable, and let me check, select at that TX isolation. Okay, so it is serializable. Now, yeah, so let's do create one transaction in the session 1. Begin and select start from T1, and in the second session, begin update T1 set name equal to h where ID equal to 1. So here you can see it is, I mean, update is even not able to process, right? Because how the serializable work, it will not allow the writes from the different sessions. What are the rows are selected in the session 1, the other users or other sessions cannot modify that data. So in this case, your select is, I mean, the rows which are selected in the transaction 1 is cannot be modified from the different sessions. So in this case, we can even avoid the phantom rows as well, right? So this is how the serializable works. So yeah, you might aware of this error. So this update ID equal to 1 is waited for the DB lock wait time mode, which is 50 seconds by default to acquire the roll lock. When this 50 seconds, this update statements wait. After the 50 seconds, it will give the timeout, lock wait timeout error. Okay. So this is how the serializable works. So means even you cannot, the rows which are selected by the transaction 1 from the session 1, those rows cannot be modified from the other sessions. So in this case, we can avoid the dirty reads, we can avoid the non-repeatable read, we are avoiding the dirty writes, and we are avoiding the phantom rows as well. These rows are consistent to the entire transaction. Once it is released by commit or rollback, then only the other transaction can process. For example, now let me commit here. Once I committed, now you can see this update is processed, and it took around 4.203 seconds, right? Fine. So now we just try to understand how these 4 types of isolation levels are working. So we also have one dedicated video for this. Please go through it. So let me give the quick overview. Read uncommitted. There we can see the dirty reads. Before the data commit, we can still see the modifications from the different sessions. With read committed, it blocks the dirty reads, but non-repeatable read is possible, which means within the same transaction, the select can produce the different result. That is the non-repeatable read. With repeatable read, we overcome the non-repeatable read behavior, but the phantom rows, we are able to see. Phantom rows means the data which are modified from the different session will not affected in the session 1, but for that same data, if there is any modification within the same transaction, then we can see the different result. That is called the phantom rows. Usually, phantom rows are not possible, so we do not much worry about it. Just for the understanding how this phantom rows or phantom reads can happens. And finally, serializable, that blocks the phantom rows as well, because it cannot allow the other sessions to write. Only the same session which hold the select, I mean, that data will be processed within the same transaction only. It will not allow the other transaction to write or modify the rows. So in that case, we are avoiding the phantom rows as well. Fine. So now this is the basic behavior of the isolation level, how it works. Now let's see about Galera cluster. So within the node, let's say I have 3-node Galera cluster. Within the node, these isolation levels will behave the same. For example, I have single primary. I'm using only one node as a primary. I'm writing on only that node. In that case, the isolation level will, I mean, what we see now, that will be for the same for that particular node. But if I have the multi-primary cluster, I'm writing on the different nodes, then how this isolation level is getting made. So for that, Galera implemented this snapshot isolation level. Yeah, let me show the example so you can understand this better. So individual node can be set any isolation level, and it will process by default behavior. That what we see now. Cluster wide, first committer wins. Okay, which transaction is committed first, that will win. That will be the committed. So, yeah. Let's go to the cluster demo. So I'm creating Galera node 1, and here I'm login node 2, and I'm creating one more session which is node 3. Okay. So MySQL. So here you can see we have cluster size is 3 and system host name -f host name -f. This is the Galera 1, and this is the Galera 2, and this is the Galera 3. We have the 3 nodes. Now let me check the isolation level. Isolation, which is okay. First node we have serializable. For other nodes we have the repeatable read. So let me make it repeatable read. So serializable not work in the Galera. Set global tx isolation equal to repeatable read. Just reconnecting and now checking. We have the repeatable read common for all the 3 nodes. Okay. So now before see the demo about this cluster wide isolation level, I just wanted to create one more session, and there I wanted to log in the second node, and I want to tail the error log here. So that error log will give some useful information about this. So I just wanted to show that. Fine. So we are just tailing the error log from the for the second node. Okay, fine. So now let's see how this isolation level, I mean the snapshot isolation level is working. Fine. System host name -f 1, 2, 3, and I'm going to do the first node. Use the first node. Begin. Then select star from T1. Oops. So 3 blocks. Select star from T1 and I'm going to update T1 set name equal to SD where ID equal to 100. Okay. On the node 1, I created one transaction with begin, and I just given the update for ID equal to 100 and changing name equal to SD. But I did not committed this transaction, or I did not roll back this transaction. This row is still open. ID equal to 100 is occur with the roll up. Now I'm going to second node Galera 2, and I'm going to do the update for the same ID. Okay, same ID 100. I'm just changing to I. Fine. Now this update is also executed, but both the transactions are not committed or rolled back yet. In the session 1 also, I did the update for ID equal to 100. In the session 2 also, I did the update for ID equal to 100. Okay. So now, if once I commit this transaction, this update will try to apply on the second node and the third node. But in the second node, the ID equal to 100 is already locked because we just started the transaction here, but we did not committed or rolled back this transaction. So this ID equal to 100 is already locked. Now if I give the commit here, what happens? That is the question here. So let's see. Here I just wanted to go through the Galera architecture. I mean the replication flow certification based architecture. So this is from the Galera documentation, Galera cluster documentation. I can share the link in the description. You can also go through it. It is very helpful to understand how the replication is happens. Let's say, so this is from client. I'm giving one update. Let's say this is the server and this is the another server. So this is, let's say this is the node 1, Galera 1, and this is the Galera 2. Okay. I'm giving one update. When I give the update, that is not going to replicate to the other nodes at the same time. Okay. It will do the native process and it will create the write set. Write set is the combination of database name, table name, data, and the primary key value. It will create the write sets. Then it will give the signal to the client. Okay, this query is executed in the same node only. It is not going to replicate to the other server. Okay. Then when I trigger commit enter, that time the write set which is prepared by the Galera 1, that will be published to the group communication system, and that replica's write set will pass to the other servers, node 2, node 3, Galera 2 and Galera 3 in our scenario. Then this data, that modification, that update will go to this node 2 and node 3. And if those nodes, the other nodes part of the cluster, that has to give you the certification. If the certification is okay, then it will commit. If the certification is not okay, it will roll back. Okay. So yeah, so now let me come here. So that is what happens here. So as I mentioned, when I give the update, that will process and it will create the write set. Now this write set for this update statement is now only available in the Galera 1. This write set is not passed yet to the Galera 2 or Galera 3. So when I give commit, then this write set will pass to the node 2 and node 3 for the certification. Okay. Now, let's, yeah, as I mentioned, this error log will be useful. Now, what I'm going to do, I'm going to commit this update on the session node 1, Galera 1. But when I give the commit, what happens? This update will try to execute on node Galera 2 and Galera 3. But Galera 3, we don't have any issues, but that is open. But in Galera 2, this ID equal to 100 is already logged, right? We are going to commit this ID equal to 100. But this ID equal to 100 is that particular row is already logged in the Galera 2. So now let's see. I'm going to give commit. Yeah. So when I give this commit, what happened? Once the commit is given, then the write set is passed to the Galera 2, the other nodes for the certification, right? Now I given the commit. So now this update is trying to execute on the node 3 and node 2. So what happens? Come to the error log. So here you can see cluster conflict due to high priority abort for threads. Okay. So here you can see this is the update what we are trying to update from the node 1, right? Then what happens? So aborted BF thread ID 100, right? So yeah, let's create more logs. For that, I'm going to session 2 and let me trigger the commit here as well. In the node 2 as well. See, it created the deadlock. Okay. And now let's try to view the data. Select star from T1 3 blocks dot T1. You can see all the nodes we have 100 SD, 100 SD, 100 SD, which is done by the first node. In the second node, what happens when I commit to this II value for ID equal to 100, we had this deadlock. Because how this works, Galera will work, the snapshot isolation. First committer wins. Okay. So who did the first commit? Node 1 did the commit here, right? So node 1 triggered the first commit. So first committer wins. So this name equal to SD is applied on the node 1, node 2, node 3. And when I am trying to do commit on the node 2, it creates the deadlock, right? So that is what here, the server itself, you can see it will trigger the deadlock if we have the conflict with the IDs. So let me come to the error log now. Here you can see you will find some, yeah. So rollbacking the aborted transaction. This connection 55 is aborted. That is the node 2 connection ID. And here you can find some information about deadlock. Yeah, here deadlock error null. And yeah, so for the queries information, you can check it here, which query created the deadlock and where, which thread was, aborted with the deadlock. So you can find some informations, useful information from the error log as well. So this is what I'm trying to explain with error log here. So this is how the isolation is work the cluster wide. Okay, so hope this is understandable, right? So we did one update, and here also node 2 also we did the update for the same primary key value, same ID equal to 100. Both are holding the row from on the each node, but when we are doing the commit, it is trying to apply on the second node, but that node is already, ID equal to 100 is already holded here. But what is the rule? First committer wins. We did the first commit on the node 1. So this data will win and this data will be applied in the cluster wide. And when I'm trying to commit the update on the node 2, I'm getting the deadlock. It creates the conflicts and created the deadlock. The deadlock, you can find some information from the error log. So I will refer this link to understand the go through, read about this documentation to understand how this certification based replication. I am also having the plan to create one video to explain the Galera cluster architecture with some examples, demo examples. So hopefully I will do that in the coming days. Okay, I will share this link in the video description. Just go through it for the better understanding. Yeah, and also as I mentioned, for the isolation level, we already have one dedicated video for the isolation level. Just go through it. You can find it in our channel. So yeah, so going forward, we have few of the topics in the pipeline regarding the history length and how the history length impact the performance and some InnoDB architecture part. We will try to understand the undo lock. So hopefully I will make it as much as possible. And also few of the people are asking how to reset the password, like my skip grants tables in the MySQL 8. And with the catching, they are not able to copy the password hash. So they are a few people are asking to have one video for that. So I will try to do that as well. And hopefully I will do the Galera cluster setup and configuration with some demo. That is all. These are the video topics are in pipeline. So if you have any interesting ideas, please share to me to make the videos, and feedbacks are mostly welcome. In case you want to see some improvements or you want to recommend some topics, please do that. Happy to take it. Yeah, as usual, in case any doubts or questions, please reach me and share the video to your friends and subscribe my channel if you did not yet. Thank you so much. Bye.